So the first example problem that we want to do deals with the first power theorem, which says that if we have two chords, then the product of the segments should be equal. So if we say 3 times x, that should be the same as 6 times 2. So 3x equals 12, and x must be 4. The next example problem we want to do deals with our power theorem that involves a tangent segment and the secant segment. So this one says that the tangent segment, let's call that x, that tangent segment squared should equal the secant segment, but we are talking about the whole secant segment, so that would be 18. 18 times just the external part, so that's 2. So x squared is 36. If we take the square root of both sides, technically our answer should be plus or minus 6, since the square root of 36 is positive and negative, but obviously NO can't be a negative length, so x is 6, and this length here, NO, is 6 centimeters. And our last example problem deals with our power theorem that involves two secants. So this power theorem says that the product of the whole secant segment, so that would be 12 in this case, times the external part, so that's 4, should equal each other. So same deal over here. So this would be PQ, let's call that x, times just the external part, which is in this case 3. So 48 equals 3x, and x must be 16. So PQ is 16 inches. Okay, so the last example problem we want to do looks like it's going to incorporate a couple different power theorems. So our goal is to find y, which is just the internal part here. So if I'm trying to find y, it looks like I could use the two secant segments AC and the other one here that ends at the circle. But the issue is I don't know this length. If I did, I could set up 3 plus y times 3, so the whole secant segment times the external part, is equal to 4 plus x times 4. But right now I don't know what x is, so I can't solve an equation, just one equation with two variables. So let's go back and see if we can figure out what x would be. If we look at the other part that's given to us, AB is a tangent segment, and A is that point of tangency. So this would be a tangent segment, and here we have a secant segment. So we also had a power theorem for that. That said that the tangent segment, which is 6 in this case, that squared should equal the whole secant segment, so that would be x plus 4 times the external part, which is just 4. So that's 36 equals 4x plus 16. If we subtract 16, we get 20 equals 4x, and x must be 5. So once we know that this inner part here is 5, we can go back and solve our original equation. So back in our original equation, 3 plus y times 3 is 9 plus 3y. And x is 5, so this really just becomes 9 times 4. So let's come down here. 9 plus 3y. 9 times 4 is 36. Subtract 9. And we've got 3y equals 27. So y must be 9.